All right, here's example 8 with reference angles. So find the reference angle for 9 pi over 7. Ugh, terrible, awful angle, 9 pi over 7. So we are going to approach it the same way we approached all the other ones though. So is this between 0 and 2 pi? First of all, this is clearly larger than 0, so we're okay there. Now we want to check, is it smaller than 2 pi? So let's write down 2 pi, get a common denominator, so multiply by 7 over 7. That's going to be 14 pi over 7. Well, yeah, 9 pi over 7 is less than 14 pi over 7, okay? Because 9 is less than 14, so 9 pi over 7 is less than 14 pi over 7. 14 pi over 7 is 2 pi, so we're good. 9 pi over 7 is smaller than 2 pi. Okay, so we're good. Now we don't have to worry about that, so let's leave this here for now, I guess. We might not need that anymore, but... So now, since we're good, we're between 0 and 2 pi, we can just go ahead and draw this. How do we draw a goofy angle like 9 pi over 7, okay? So if we go to the unit circle, we don't have anything over 7, right? We got pi over 6, something over 4, over 3, over 2, just stuff like that. Okay, so nothing over 7. Well, we're going to think about it just like we did with example 7 in the previous video. Okay, but it's slightly more complicated because in example 7, our denominator was 8, right? So that was an even number, so it was a little simpler for us. But here, our denominator is an odd number, so it only makes things just a tiny bit more complicated. Not even that much worse, but it's still, it's going to be a lot like the previous video. Just one tiny extra step. So, okay, let's actually erase this now, we don't need that anymore. Okay, so what we do, let's just approach it the same way. So what do we want to do? We want to figure out what quadrant is this guy in. Okay, once we get the quadrant right, we can draw this semi-accurately. All we care about is the quadrant. And then once we get that, we can get the reference angle. So how do we get the quadrant? Well, we say, okay, pi over 2 radians. Okay, if I start here at the vertex at the origin, initial side on the positive x-axis, because we're talking about angles in standard position. So pi over 2 radians puts me up here. Okay, pi over 2 puts me up here. Now I want a common denominator. Well, 2 and 7, common denominator is going to be 14, right? So first what I do is I say, okay, 9 pi over 7, if I multiply by 2 over 2, that's going to be 18 pi over 14. Okay, so 18 pi over 14, this is the guy I want to compare stuff to, because 9 pi over 7, 7's not a good number to compare stuff to on the unit circle, but 18 pi over 14, that works a little better because 14 is even. Okay, and since we just multiply by 2 over 2, then 18 pi over 14 and 9 pi over 7, they are the same thing, so it's okay to do this. So pi over 2 multiplied by 7 over 7, so we get our common denominator. So this is 7 pi over 14. Okay? So pi over 2 radians is the same thing as 7 pi over 14 radians, puts us up here. Well, hey, 18 pi over 14 is still larger than that, so let's keep going to the next one. The next one is pi. Okay, pi radians puts us over here. So this is pi radians. Now if I take pi, get a common denominator, so multiply by 14 over 14. Or really, with this one, I could do 7 over 7, it's just pi. I could, but to keep it consistent, why not? Let's just keep going with this. Plus I already wrote it anyway. But again, if you wanted to, you could have used 7 here. That's fine, totally fine. So pi times 14 over 14 is 14 pi over 14. Well, hey, 18 pi over 14 is still larger than that, so we got to keep going. Or if you wanted to do 7 over 7 instead, if you insist on that, you could say pi times 7 over 7 equals 7 pi over 7. Okay. And, well, hey, 9 pi over 7 is still larger than that, so we have to keep going. So whether you use 7 or 14, either way you'll see you have to keep going. So again, what are we doing? We're trying to find two angles here to bound this guy, right? 9 pi over 7 or 18 pi over 14, same thing. We're trying to bound this guy between two of these quadrantal angles here. So remember that definition from way back, quadrantal angles on the axes. We're trying to bound those this angle here between two of these guys so that we can find out what quadrant this guy's in. That's all we're trying to do. Okay. So this one is too small still, so we go to the next one. The next one is 3 pi over 2. Now we have to use 14 again. 3 pi over 2, get a common denominator that's multiplied by 7 over 7. So this is going to be 21 pi over 14. Oh, that's great, because 18 pi over 14 is less than 21 pi over 14. Okay, so what we just found out was that, so let's put this one back in terms of 14s, just to be consistent. So this was 14 pi over 14. Okay, so what we have here is 14 pi over 14 is less than 18 pi over 14, which is less than 21 pi over 14. Okay. 14 pi over 14 is this angle right here. 21 pi over 14 is this angle down here. 18 pi over 14 is the angle that we have, or the same thing as 9 pi over 7. Okay, so this 9 pi over 7 is between this angle and this angle. So 9 pi over 7 is somewhere here, maybe a little bit closer to this one. But again, it doesn't matter. We just want to get the quadrant right. Okay, so here is 9 pi over 7. Okay. So again, it's really just like example 7, but the only tiny extra step was this common denominator thing was a bit more complicated. Okay, but it really is exactly the same thing as example 7, just a little more complicated because of the denominator being an odd number, but still exactly the same way. Okay, so continuing with this, if we have an angle in quadrant 3, how do we get the reference angle? Well, what we do is, for the reference angle, we take this entire angle, subtract off this pi, because if we subtract off the pi, we'll be left with just this, and this, okay, or this, is just what we want. Okay, so this angle here is just, that's what we want, so we take the entire angle, 9 pi over 7, subtract off pi, and that'll give us what we want. So pi common denominator multiplied by 7 over 7, so this is 9 pi over 7 minus 7 pi over 7, okay, which is 2 pi over 7. And if you've been following along with the other examples, what do you notice? It's not just some pi over a number, right? It's we have a number on top. So remember, with our simpler examples, the answer were like pi over 6, pi over 4, pi over 3, and stuff like that. But for this now, since we have a goofy angle, something over 7, the answer is not just pi over 7, like you might hope or expect. But sadly, no, it's more complicated than that. So for this one, the answer is 2 pi over 7. Okay, so again, just a quick recap of what we did here. First, we asked ourselves, is that between 0 and 2 pi? It is, great, so now we draw it. How do we draw that angle? That's a goofy angle. I don't know what it is. It's not in the unit circle. What do I do? Try and find 2 of these angles on the axes to bound this guy between. Okay, and you can always do that. If it's between 0 and 2 pi, okay, it's going to be stuck between these two guys, between this guy and this guy, or stuck between this guy and this guy, or this guy and this guy, or this guy and this guy. Okay, because if it's between 0 and 2 pi, it's got to be bounded between some pair of these. So just keep going like this, do the common denominator thing. So we did that, we said, okay, 7 pi over 14 is less than 18 pi over 14. 18 pi over 14 is 9 pi over 7, remember? So 7 pi over 14 is too small, go to the next one. 14 pi over 14, too small, go to the next one. 21 pi over 14, there we go. So 14 pi over 14 is less than 18 pi over 14, which is less than 21 pi over 14. So our given angle, 18 pi over 14, or 9 pi over 7, is between these two guys here. Okay? So that's how we found out it's in quadrant 3. And then quadrant 3, you do the given angle minus pi. And again, we don't want to memorize that, right? Don't memorize that quadrant 3 is that minus pi, because it's easy to confuse with quadrant 2. But just think about, once you draw the picture, just think about what it is and what you have, what you know, and what you want. Okay? So I know 9 pi over 7 is here. I want to subtract off this piece so that all I have left is this piece. So 9 pi over 7 minus pi gives me what I want. And what I wanted was 2 pi over 7. Okay? So that's example 8 with reference angles, a tiny bit more complicated than example 7, but really all the same. So that's example 8 with reference angles, 2 pi over 7.